Hi everybody, today we're going to be doing lesson 2 of our booklets. This lesson should be really quick because we have already covered a lot of this in the previous video, quicker, but we'll do it a little bit more thoroughly. So we're going to be defining the precipitate and then writing the net ionic equations. So here's the reaction we did last time. Silver nitrate plus sodium chloride gives us silver chloride, which is a solid, has a low solubility due to the solubility rules, the strong attraction between silver and chlorine, and sodium nitrate is going to still be in solution. We said something about how there are spectator reactions in this, spectator ions. The sodium will be a spectator and the nitrate will be a spectator because they both stay in the aqueous phase on both sides of the equation. So one way of thinking about this is this little statement here. The molecular equation is not an accurate representation of what is actually occurring. It does not give us an indication of the contents of each solution, or it does give us the contents of each solution, but we do not know which ions are going together. So this is where a net ionic equation could be valuable. So here's our dissociation equation. Here's our other dissociation equation. We take those two dissociation equations and combine them, we can see that the reaction would look like this. It's a bit much. It's got a lot of parts to it, but we can see things that are on both sides of the equation, and we know that things on both sides of the equation mean they have not changed, so they can go away. And so as we remove those chemicals from our equation, here's another, we're going to do it again because this book repeats itself a little bit. We end up with a so-called net ionic equation. So, and this net ionic equation specifically focuses in on what things are involved in the chemical reaction. What concentrations are going to be important for figuring out how much precipitate is going to form. So let's write out one full set here. We have lead 2 nitrates, so that's PbNO3. And notice that nitrates have only a -1 charge, so if it's lead 2+, we need 2 of those. And we're going to say that's an aqueous. And we're going to be adding that to potassium iodide. So this is also another reaction we've done on the previous booklet. This is going to give us lead iodide. Iodine and nitrates have the same charge, so we know that we're going to get the same number of them joining up with that lead. And potassium and nitrate are also +1 and -1 charge. So if we go and look up our rules, we'll find that anything with a first row metal, an alkali metal, is going to be soluble, so we can write aqueous, and anything that mixes with halides is soluble except for lead and a couple of other compounds. So here is our molecular equation. Let's write out the ionic equation. So anything that is aqueous is going to be separated out into its ions. Sort of wish there was a faster way of doing this, but there isn't. Minus aqueous. Oh, is my previous equation balanced? No. Notice the 2 over here. There's only 1 here, so we need to get a 2 going on there. And we got now 2 potassium, so let's clean that up. Okay, let's split up those potassiums. There's going to be 2 of them because we have 2 units there, as we just fixed in our equation. And we have 2 iodines, which is also going to be aqueous. And then those are reacting. This gives us our lead iodide, which is our precipitate, so it's solid, plus any remaining ions. And in this case, we have the remaining potassium ions. There's 2 of them, and they're aqueous. And the remaining nitrate ions, NO3. And there's going to be 2 of those as well. So 2NO3. And there's an aqueous up there somewhere. Okay. Hopefully that works for you. We can see that there is some cross out that we can happen. The potassiums are on both sides, and so the final net equation is simply to take the lead, 2 plus aqueous, and add that to 2 iodines, aqueous, and then this causes the creation of lead iodide. That's an S. There we go. Okay, so there's our 3 reactions. Yeah, I find that as you get with practice, this equation should be enough, but it is valuable to realize that even though you have all these compounds that you're mixing, these 2 different compounds you're mixing, all that really matters is how much iodine and how much lead you need in solution. This could be important later where maybe you do something like, I'm just trying to think of a thinking problem. What would be a problem that we would worry about this? Well, what if you had a solution of a lead nitrate and someone said, hey, what if I want to mix some lead nitrate, some potassium iodide, and some calcium iodide? I don't know. And so in this case, we have iodine from 2 different sources and only 1 source of lead. This could be a really complicated problem, but probably in the end, it's only going to be making lead iodide, and everything else is going to be soluble. So it'll actually have the exact same net equation. So this is just a thought experiment. I don't actually want you to write this down because it's way too complicated an experiment to explore, but probably much more likely if we were talking about something like the water supply, right? Lead in our water supply is a big concern, and of course in our water supply there's also the possibility of many other different types of salts. So if you have a large combinations of salts, you might not even know what the sources of all the ions in your solution are. And so, or if you're talking about a lake, a natural resource, it has all these different salts coming in from different types of rocks at the bottom of the lake, all sorts of sources. So we have to think about specifically what precipitates are we seeing, and then just kind of mapping out which ions are actually active and being used. I'm going to just even delete this from the main notes because I don't want this to be stuck around. I don't want you to worry about it later. Okay. All right, so here's a bunch of practice for that, and I believe that's it. I think that's the lesson. So we'll talk about lesson 3 in a sec.